All right. Okay. Section 2.15 is not a section in your book, but we are going to do a bit of equation review today. So our objective, we're going to solve linear equations using addition, subtraction, multiplication, and division. So first we have to talk about what an equation is. An equation is a statement that two expressions are equal. So we're taking our expressions from the last sentence, last section, for example, the 1.05p minus 50, okay, and then setting it equal to another expression, let's say 700. So let's say I've got $700 to spend and I want to figure out how much a phone, how expensive of a phone can I purchase, like our phone problem from the last section. Okay, so important part here is the equal part. An equation has an equal sign. So, for example, straightforward, x plus 6 equals 12. Okay, so again, it's saying two expressions, my two expressions. Here's one expression, x plus 6. Here's the other expression, 12. And the one expression isn't always necessarily a number. For example, 2x plus 5 equals 3 parenthesis x minus 2. Okay, that is again an equation because it has that equal sign. Okay, so and not all equations have variables. 8 plus 2 equals 7 plus 3 is an equation. It has an equal sign. It's two expressions. Here's my one expression, 8 plus 2. Here's my other expression, 8, 7 plus 3. Okay, but again, for me to use that equal sign, the two expressions have to be equal. So this is the example of a closed equation in that we know everything. We know all the numbers. There are no missing pieces. These ones over here, this one and this one and this one, are what we call open. They have a missing piece. And that missing piece is that variable part. Here, I don't know what p is. Here, I don't know what x is. Here, I don't know what either of these x's are. Okay, so a solution of an equation is a value that makes the equation true. So we're looking for a value for the variable. Okay, and let's go ahead and let's add that word. Is a value for the variable that makes the equation true. A closed equation has no solution. This has no solution because there's no missing piece we need to find. Okay, so to find these missing pieces, we're going to use what are called inverse operations. Inverse operations are two operations that undo each other. The two most standard inverse operations are add and subtract. Okay. But more so positive and negative. Okay. For example, a positive 6 plus a negative 6 undo each other and give me 0. So we're going to be using it kind of more that way, but the inverse of add is subtract. The inverse of subtract is add. The opposite of a positive is a negative. The opposite of a negative is a positive. Okay. And then the other one is our multiply divide relationship. Okay. Multiply and divide are also inverse operations. Okay. Equivalent equations. These are basically equal equations, are equations that have the same solutions. Okay. For example, the equation x plus 5 equals 11. Okay. 2x equals 12. These are actually equivalent equations because the solution to this first one is 6. X has to be 6. And this one, x also has to be 6. So these are what we call equivalent equations. Okay. So to be able to take an equation, we're going to be taking equations today and finding solutions or solving them. And to do that, we're going to be using our properties of equality. Basically, what a property of equality tells me is if I have a true equation, okay, for example, if I have a true equation, 8 plus 2 equals 10, okay, a true equation. 8 plus 2 does equal 10. It is true. I can add the exact same thing to both sides and it keeps it true. I can take this side, my 8 plus 10, and I can add 15. I can take the other side and add 15. So again, there's my two sides. So here's my 8 plus 2, my 8 plus 2. I added 15. I added 15. There's my 10. And it still be true, meaning I can still use an equal sign between them. So I can add the same thing to both sides. Okay. It's still true. Okay. So I can add the same thing to both sides and it still be true. Same holds for subtraction. I can subtract the same thing from both sides. But really with subtraction, we're going to do a lot more of adding negatives to both sides instead of subtracting. So a little star here, we're going to do more of adding negatives to both sides instead of subtracting. But yes, subtracting is still, we can still subtract the same thing from both sides and it still be true. Same with multiplication. You can multiply both sides by the same thing. If I have my 8 plus 2 equals 10. If I take this whole entire side, this 8 plus 2, and multiply it by 3, again, I have to have parentheses here because I'm taking that whole side and multiply by 3, and take the other side, this 10, and multiply it by 3. It's still going to be true. This side will be 30. This side, even if I distribute, it'll still be true. Okay? And from our last section, we had that distributive property. 3 times 8 is what? 24. Plus 3 times 2 is 6. I still get 30. It's still true. And dividing both sides. Okay, so we are going to be taking equations and we're going to be adding, subtracting, multiplying, and dividing both sides by the exact same thing to do what we call isolate the variable. So we want to isolate. What does it mean to isolate? Get by itself. Isolate the variable in solving these. So here I have two equations and I want to solve them. This first one is x minus 3 equals negative 5. The first thing I'm going to do to prevent negative errors, I'm going to rewrite this as x plus the opposite of 3, negative 3, equals negative 5. And then I'm going to find the variable. That is my only variable. There, my x, just have the 1. So I need to get that variable by itself. So ask myself, what's happening to that variable? If I knew what that variable was, what would I do to it? Like if I knew x was 10, what would I do? Well, I'm adding a negative 3 to it. So I want to undo adding a negative 3. Okay, so what's the opposite of adding a negative 3? Well, the opposite of negative 3 is positive 3. So I'm going to add a positive 3 to both sides. So I'm going to write the same side as is, and I'm going to add a positive 3 equals negative 5. And then again, we're going to add a positive 3. So now I look at this left side of the equation, and I put together like terms. Okay, these two here are alike. They're both numbers. I have a negative 3 plus a positive 3. That gives me 0. If you don't get 0, you added the wrong thing or subtracted the wrong thing. So you don't just cancel them. They don't just cancel. Negative 3 plus positive 3 is 0. So I end up with x plus 0, which I'm just going to write as x. And then on the other side, I take negative 5, add 3, it's negative 2. So this is telling me that x should be negative 2. Now, it's always a good idea to check your work. Okay, so here I'm saying if x is negative 2, so I'm replacing my x in here with a negative 2 minus 3. Does that equal, I'm going to put a question mark on top, does that equal negative 5? Negative 2 minus 3, that's negative 2 plus a negative 3, does equal 5. Check, it worked. And if you're not sure, totally calculate that. Negative 2 minus 3, negative 5, it worked. So here again, we were using this idea that I can take both sides, add a 3 to both of them, and it still be a true equation. Okay. The next one, again, start first, find your variable. My variable is right here, y. What is happening to my y? I'm adding 2.8. Okay, so I want to undo, I want to get that variable over there by itself. So I want to undo and add 2.8. So the opposite of a positive 2.8 is a negative 2.8. So I'm going to add a negative 2.8 to both sides. So I'm going to take this left side and I'm going to add a negative 2.8. Again, notice how I put it on the end. And then y plus 2.8. I'm going to add a negative 2.8. So I took both sides of the equation. There's my original equation right there. And then I added a negative 2.8 to both sides. Because again, it's using that addition property of equality. Okay, and then now, so on this left side, I take 0.9 and add a negative 2.8. If I don't know, 0.9 plus a negative 2.8, I get negative 1.9 equals, now double check on this side, are these opposites? Are they going to undo each other? Positive 2.8 plus a negative 2.8 gives me 0, so I end up with y plus 0, which is just y. Okay, oftentimes we like to flip-flop, and equality can be flip-flopped. Okay, now we want to check it. Is 0.9 equal to negative 1.9 plus 2.8? Question mark. Did it work? So negative 1.9 plus negative 1.9 plus 2.8 is in fact 0.9. Check, it worked. All right. Next, we've got some multiplies or divides. Don't let this first one freak you out. That is just a division. It is n divided by 5. Oh, we can't forget that negative. That negative has to apply to one or the other. This negative either has to be on the n or it has to be on the 5. Do whatever's easiest. I think a negative on an n is going to complicate things, so I'm going to put it on the 5. So I have n, I'm going to rewrite it, divided by negative 5. Oh, I should do that blue. Sorry. N divided by negative 5 equals negative 3. So now I found my variable. My variable is right here. What is happening to n? If I knew what n was, what would I do to it? Divide by negative 5. What's the opposite of dividing by negative 5? The opposite of divide is multiply, so I need to take both sides, this side, multiply by negative 5. The other side, multiply by negative 5. Okay, so now if I multiply this out, this is negative 5 over 1. I would get negative 5n over negative 5. Okay, or negative 5 over negative 5 times n. Negative 5 divided by negative 5 is 1. So when I divide these, I get 1. So I have one single n. So there is my one single n. Again, if we just have one of them, we don't put anything in front of it. Equals, and then now on this side, this is a multiply. Negative 3 times negative 5 is positive 15. Again, I'm going to come over here to the side. We want to check it. What's so nice about these problems is you can check every single one of them to make sure it works. So replace your n here with the 15. 15. Negative 15 divided by 5. Does that equal negative 3? Does it equal negative 3? Yes, it does. 15 divided by 5, negative. Okay. Next one. Ooh, we have some irrational stuff here. We have pi. Pi is just a number, like 3.14. So again, just like our last problem, we're going to figure out where our variable is at. My variable is right here. What's happening to my variable? It's got a pi next to it. If there's a number next to a variable and nothing in between, it's a multiplication. So this is pi times x equals negative 2 times pi. So my variable is right here. There's my x. It's being multiplied by pi. So how do I undo a multiply by pi? We divide. So I'm going to do a divide. I'm going to draw a divide by as a fraction bar. We're going to take both sides and divide by pi. So pi. So really on this side, I have pi divided by pi times x. And on this other side, I have negative 2 times pi divided by pi. Well, pi divided by pi here is just 1. Pi divided by pi here is just 1. So that tells me that x equals negative 2. So go ahead and check it. Pi times, replace that x with a negative 2. Does that equal negative 2 pi? Yes, it does. No work required. Multiplication is commutative. Okay. Next one, here we got some decimal problems. Again, find my variable. There it is. There's my z. Okay. And then ask myself what's happening to the z. It's got a 1.3 in front of it, so that tells me it's a multiply. So I have 1.3 times z. Okay. The inverse operation of multiply is divide. So we're going to take both sides and divide by 1.3. 1.3 divided by 1.3 is 1. So I'm left with 1z. Now I just need to take 5.2 and divide it by 5.2 divided by 1.3. 4. Well, that's nice. It goes in evenly. Again, check it. And very often your check can just be a calculator. Take 1.3 times 4, and I do, in fact, get 5.2. Okay, these checks are pretty straightforward. We're going to get into two-step equations now, which the checking is a little bit tougher. Okay, so I'm going to show you a method of solving two-step. This is a two-step equation because there's two things going on. I've got a multiply, and I also have a subtract, which I'm going to come in. First thing I'm going to do is rewrite that subtract. 2x plus a negative 3 equals 15. I'm going to show you a method called mapping that is really helpful in helping you undo, because I need to undo both of these operations. I need to undo a multiply. I need to undo this multiply, which is going to be a division, and I need to undo this multiply adding a negative 3, which is going to be adding a positive 3. But very common mistake is knowing which order to do it in. So mapping is very helpful for that. So what mapping looks like. I start here, it's just basically these bubbles. I start here with a bubble, it's got my x in it. If I knew what x was, if I knew like x was 15, what's the first thing I would do to x? We're going to draw an arrow. The first thing I would do to x to get to my next bit is multiply by 2. I take x, multiply by 2, and get something out. When I'm done multiplying by 2, next I come in and I add a negative 3. So we're going to go ahead and draw another arc. We're going to add a negative 3. And I get my final answer out. And my final answer should be 15. Okay. So in much the same way, putting on your socks and shoes. When you put on your socks and shoes, the first thing you do is put on your socks, and then you put on your shoes. To undo it, you have to undo it in the backwards order. Take off your shoes, then take off your socks. So to put on your socks and shoes, first you do socks, then shoes. Let's say then you tie them. To undo it, you have to untie first. So this is the first thing you do, second and third. But to undo, the first thing you have to do is untie them, and then take off your shoes, and then take off your socks. You do it in the opposite order, much the same as solving an equation. So here, this original order, we took the x multiplied by 2, and then added the negative 3. To undo, we need to do it backwards. So I need to go to that 15. Instead of the opposite of adding a negative 3 is adding a positive 3. So I take my 15 and I add 3, which 15 add 3 is 18. Okay, and then to get from this bubble to this bubble, I need to undo this multiply by 2. Undo multiply by 2 is divide by 2. 18 divided by 2 is 9. So this tells me that my x has to be 9. Okay, I solved this using mapping. Again, I still want to check this. If x is 9, 2 times 9 minus 3, does that equal 15? 2 times 9 is 18. 18 minus 3 is 15. Check, it worked. Okay, so this is one in which I used mapping, and you can use this method for many of your problems. I just would need to see the map. I will tell you this doesn't work for all problems. If there's more than one variable, if there's more than one x in the problem, this will not work. Okay, so now I'm going to show you how to do one without mapping. Okay, so here's my equation. 2.5x, again, I'm going to start by rewriting it as plus a negative 13 equals 2. So again, to undo this, I look at my x, just the same as last one. I find my variable. Here's my x, and I ask myself, what's happening to my x? What's the first thing, if I knew what x was, the first thing I would do to it is multiply by 2.5, right? First thing I would do is handle this. Order of operations, do the multiply first, and then I would add a negative 13. To undo it, I need to undo it in the backwards order. So the first thing I have to undo is the add the negative 13. So to undo adding a negative 13, I add a positive 13. So I write this equation as is. plus a negative 13, and then I add a positive 13. The other side of the equation, I add a positive 13. So now I put together like terms. These two are alike. So this side just aims 2.5x. Positive 13 plus a negative 13 is 0. So that gives me plus 0, which I can write it, but adding 0 means nothing. 2 plus 13 is 15. So I have 2.5 times x equals 15. So I undid this step, check, done with that bit, adding a negative 13. Now we need to undo my multiply by 2.5. To undo a multiply by 2.5, I need to divide both sides by 2.5. 2.5 divided by 2.5 is 1, so I have 1x. And now 15 divided by 2.5 is 6. X equals 6. So now I'm going to check my work. So to check my work, I come back to my equation, take 2.5 times 6. 2.5 times 6. Add a negative 13 or subtract 13, either way. Oh, it's supposed to be 2.5, sorry. Times 6, subtract 13. I get 2. Is that what I was supposed to get? Yep, 2. Check it. Check, it worked. Always check your answers. Okay. All right, we have a couple more to do. Slightly different problems. This one, again, first thing, find your x. There's one. Uh-oh, there's another. So the first thing I have to do is get all my x's together. They're like terms, so I can add them. So negative 12 equals, I'm going to rewrite my subtract as plus a negative. You'll notice I do that a lot. That prevents so many negative errors. So now let's put together these like terms. I have a 9 plus a negative 6. They're not the same, so I subtract. 9 minus 6 is 3. Use the sign of the bigger number. Again, everything else stays the same, and we try to, if you notice, we line up equal signs whenever possible. That is how mathematicians do their work. If you notice here, line up equal signs, line up equal signs. That is just standard, so I kind of expect that in your work. Show each step, line up your equal signs. Again, don't lose my x's. There's my x. So again, off to the side, if I knew what x was, if I knew what this number was, let's say it was a 2. The first thing I would do sorry, that went all crazy. The first thing I would do is multiply by 3, and then I would add the 15. So to undo it, I undo it backwards. So I need to undo the add 15 first. So I need to undo add 15. I'm going to add a negative 15 to both sides. Equals 3x plus 15 plus a negative 15. Oh, sorry, just making it red so we can see the original equation. So now I put together like terms. Over here, these are both just numbers. They're both negative, so I can just add them. Negative 12 and negative 15 is negative 27. Now over here, positive 15 plus a negative 15 is 0, so I'm left with 3x plus 0. So now I undid the add 15. Now I need to undo the multiply by 3, which is divide by 3. Divide both sides by 3. 3 divided by 3 is 1. Again, they don't cancel. 3 divided by 3 is 1. That's all we're doing, is we're just dividing. X equals negative 27 divided by 3 is negative 9. X equals negative 9. So again, we're going to check our work. Wonder if it'll let me do this. Okay, so to check this, I'm going to plug in a negative 9 in for both of my x's over here. So I'm going to take 9 times negative 9 minus 6 times negative 9, and then add 15. If it worked, I should get a negative 12. Woohoo, it worked. So again, always check your work. No, by calculator. So we checked it. Yep, it worked out. Okay, last one. First glance, this one might look intimidating because it's got a fraction. Remember, that's not a fraction, that is a divide. Okay, dividing and fractions, same thing. So to solve this one, again, I'm going to find my variable. My variable is right there, my q. If I knew what q was, the first thing I would do to it, let's say q was 15. I would subtract 3. So the first thing I would do is subtract 3. And again, it does help to create the list off to the side. After I'm done subtracting 3, I divide by 2. So I need to undo this in the opposite order. So I need to undo the divide by 2 first. The opposite of divide 2 is multiply. So I'm going to take both sides, multiply by 2. So I'm taking this left side, multiply 2. equals this right side, q minus 3 divided by 2, multiply by 2. So this is a 2 over 1. So really here I have 2 divided by 2, which is 1. The left side, 2 times 2 is 4. So 4 equals q minus 3. So now that I undid the divide by 2, check, I can now get rid of my subtract 3, which is the same as adding a negative 3. So to get rid of an add a negative 3, I need to add a positive 3. Q plus a negative 3 plus a positive 3. My negative 3 plus a positive 3 there is 0. So I'm left with q plus 0, which is just q. 4 plus 3 is 7. So I get q, if you want to flip it around. You don't have to. Q is 7. Again, let's check my work. So back to the original problem. If I know q is 7 and I subtract 3, be careful. If I just hit divide by 2, it's not going to work. I get 5.5, not 2, because your calculator, it does order of operations, so it's doing the divide first. So to make sure I do the subtract first, it's going to need parentheses if I want to do it all in one step. I take 7 minus 3 first, then divide it by 2. That works too. Or you can do it in 2 steps. 7 minus 3 equals 4 divided by 2 equals 2. Okay, so check, that one worked.